Okay, this is 7.5 inverse trig functions. So last week we were looking at trig ratios to solve for a missing side length given a known angle and a known side length. This week we're using inverse trig functions to find a missing angle given two known side lengths. Okay, so let's take a look at this example here. Says, what angle of elevation should Spider-Man sling his web up in order to hit the lizard? Okay, so the angle of elevation here is this one here. I'm going to use this Greek letter theta. You can use whatever variable you want. I'm going to use theta. Okay, so we have this missing angle. We have these two known sides. So let's go ahead and identify um, what these sides are in terms of this angle. So this side length here, 435, is next to the angle, but not the hypotenuse. So this is the adjacent side, and across from the angle is going to be our opposite side. And this, the longest side, is of course our hypotenuse. The two side lengths that we know are the opposite and the adjacent. So which trig ratio are we going to use? Let's review these really quick. We've got sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In other words, the shorthanded way to say this is so, ka, toa. All right, but for this example, we have opposite and adjacent. Which ratio uses that? That would be tangent, opposite over adjacent. So we're going to set this up as the tangent of theta is equal to 125 over 435. Okay, so we have this equation. The tangent of theta is equal to 125 over 435. So we need to isolate the variable, just like with any equation. Okay, so how do we do that? Well, just like with any equation, let's go with a basic one like 2x is equal to 12. This is 2 times x is equal to 12, so we do the inverse or opposite operation, and we divide, and we isolate the variable. Okay, so we are going to do the opposite of tangent. We're going to do the inverse of tangent. Okay, and this is going to end up canceling out, and you're just going to be left with theta on the left side. And if you do it on one side, you need to do it to the other side. So we're going to do the inverse of tangent of 125 over 435. And let's see what we get. So I'm going to pull up my calculator here. To access the inverse functions, we need to hit the secondary key. So we're going to do the inverse of tangent. And we'll hit our n over d key. That's our fraction key. And we're going to do 125. Click our arrow key down to get into the denominator. And 435. Press enter. So to answer our question here, what angle of elevation should Spider-Man sling his web up in order to hit the lizard? Looks like 16 degrees. Okay, so let's take a look at some more examples here. We're going to be solving for the missing angle. So the first thing we want to do is label our sides. So in terms of this angle here, we have our opposite side that's not touching the angle. We have the hypotenuse that is across from the right angle, and we have the side that's next to the angle but not the hypotenuse, and that is our adjacent side. We're not going to need the adjacent side, but I think it's good practice to label every side out. So we are given a side length for the opposite and hypotenuse. So which trig ratio uses opposite and hypotenuse? And that is going to be sine. Okay, so the sine of theta, you can use any variable you want. I'm going to use theta, is equal to opposite over hypotenuse. So 5 over 15. Okay, so now we need to undo sine. So we use the inverse of sine. And if I do it to one side, I need to do it to the other. So I'm going to take the inverse sine of 5 over 15. The right side, or sorry, the left side will cancel out, and I'll just be left with theta. And we'll go to the calculator for the right side. So we're taking the inverse of sine, so we need to hit the second key. There we go. And now we'll hit our fraction button, 5 over 15, and press enter, and we're left with 19. Remember, we're going to round this to the nearest whole number. So our angle is 19 degrees. All right, moving on. Example 2. So now we're looking at this angle here. So let's go ahead and label the sides. We've got the side across from the right angle. That is our hypotenuse. And got the side that is next to the angle, but not the hypotenuse. That is our adjacent side. And again, not needed for this problem, but let's go ahead and label it. Across from the angle is our opposite. Okay, so which trig ratio uses A over H? I'll write this out real quick here. So Katoa, which one uses A over H? That is going to be cosine. So let's do the cosine of theta is equal to A over H. So this can be 42 over 44. And now we just need to take our inverse of cosine. So if we do the inverse of cosine, and you don't actually have to write this all out every time on the left side. And I think I'm going to stop after this one. And if I do it to one side, I need to do it to the other side. So I take the inverse of cosine of 42 over 44. Left side's going to cancel out, just going to be left with theta is equal to, go to the calculator next. And what are we looking? Let's see if I can get this over here. Hit the second key, inverse of cosine of fraction key 42 over 44. Remember, we're going to round to the nearest whole number, so we're looking at 17 degrees. So our missing angle is 17 degrees. All right, last example here, example 3. First thing we want to do, label our sides in terms of this angle. All right, we have our side that is next to but not the hypotenuse. That is going to be our adjacent, and the 25 that is across from the angle. So this is our opposite. And again, we don't need it for this problem, but this is our hypotenuse across from the right angle. So which trig ratio uses opposite over adjacent? That is TOA or tan. So we're going to take the tangent theta is equal to O over A, so 25 over 33. And now we just undo this. So we're going to do theta is equal to the inverse of tangent of 25 over 33. All right, let's go over to the calculator. Get this on there. There we go. Second key, tangent button. We get the inverse of tangent of fraction key 25 over 33. Press enter, and we're left with 37. Rounded to nearest whole number, that would just be 37. So theta, our missing angle, is equal to 37 degrees.